Hey everyone. So here's a question. How many times have you used the internet today? Checked your phone, sent a message, watched a TikTok? I'm guessing constantly. But here's the thing, most of us have no clue what's happening when we click send or load a website. So today I want to talk about how the internet works. And I think understanding this stuff is honestly pretty crucial for anyone working in tech, which is most of us at this point. All right, let's start with this map right here on the top left. So this map shows the real internet, not the wireless cloud-based thing that you're imagining. And these lines that you see here, those are massive fiber optic cables sitting on the ocean floor. And we're talking about over 99% of all international internet traffic flowing through these physical cables. And what really blew my mind when I first learned about this is that these cables are often just the width of a garden hose, and inside is a strand of glass fiber about as thick as a human hair. So, if you post an Instagram story right now, it'll literally travel across the Atlantic Ocean as pulses of light through this tiny glass tube. And the crazy part is, how vulnerable this all is. Um, in 2019, I think the country of Tonga lost internet access for 13 days because a ship's anchor cut their main cable. And sometimes sharks also bite these cables, and there's actual footage of this happening out there if you want to go check that out. But yeah, and also now I want to give an example of how data moves. So in this case, let's talk about sending a photo to your friend. Now this story gets really interesting. First, your phone takes that photo that you took and chops it up into thousands of tiny pieces called packets. So think of it tearing up a letter and then stuffing each piece into separate envelopes. Now each packet, they get labeled to with where it came from and where it's going, and that's the IP address system working. Then your phone converts all these packets into binary code, just one and zeros. So every single pixel of your photo now has become a sequence of one and zero. Um, then your phone sends these as radio waves to your Wi-Fi router, which then takes these radio waves and converts them to light pulses that shoot through these fiber optic cables to your internet service provider, or your ISP, which are companies like AT&T and T and Verizon. So as you see here, all the packets that are now ones and zeros will be traveling through this fiber optic cable here as pulses of light, where a flash of light means it's a one, and when it's not flashing, it means zero. And now here, these packets don't all take like the same route to your friend. Some might go through New York, others through Chicago, some might literally cross an ocean, and they're all racing through this massive network of routers and switches, each one making a split-second decision about the fastest path. And finally, once they all arrive to your friend's phone, they get reassembled in the right order, and then they see your photo. And this entire journey happens in milliseconds. So let me break down the main pieces that make this possible. So first, are the IP addresses. And these IP addresses are basically digital street addresses. So every device connected to the internet has one. Your phone, your laptop, Google service, Netflix service, they all have unique IP addresses. And that's how the data knows where to go. Then there's also the DNS, which is the domain name system. It's like the internet's phone book. So when you type google.com, your computer doesn't actually know, where that is. DNS looks it up and says, oh, that's actually 172.217, whatever the IP address is, and then you don't actually see those numbers, but that's what's really happening behind the scenes. Then the ISPs, which are the internet service providers. So these are again like companies that like AT&T and Verizon that actually connect you to the global internet. So they own the cables, the infrastructure, the big routers. And here's something important. In many areas, you only have one or two options for ISPs because um, it's incredibly expensive to lay cables and build infrastructure. So many companies just avoid areas that aren't profitable enough. And I'll go into this later. But and then another main thing are the routers. So routers are like the traffic directors. So every time a packet needs to find its way somewhere, routers look at the address and say, the best path is that way. And they're making millions of these decisions every second. And everything, literally everything, gets broken down into packets. So your email, the Zoom call that you guys are on, if you're watching Netflix, a Netflix stream, all these, it's just all packets flying around and getting reassembled. So I want to talk about what happens when you type in a website. So say you want to check on Instagram.com. So first, your computer asks the DNS, hey, what's the IP address for Instagram.com? And then DNS comes back with something like 157 dot something like the IP address for Instagram.com. And this picture kind of shows what's happening. So once you type Instagram.com, it'll go to the DNS resolver, which goes through these DNS servers, and like eventually it sends back the IP address. Then your browser then sends a request to the IP address saying basically, hey, can I have your homepage? So it goes to the Instagram servers, and then the Instagram servers receive these requests, gather up the HTML code, images, videos, whatever makes up the homepage, that into packets, and send it all back to you. Then once your browser receives these packets, it puts them back together in the right order, and then renders the website that you see. And this whole round trip happens in milliseconds, but it's a delicate chain. So, for example, if the DNS is slow or if the server is overloaded, and if there's congestion somewhere along the route, you get that spinning loading wheel, the loading icon. So, even though this is like even though this happens in milliseconds, even if one thing is slow, the whole process is slow. So now I want to go into data centers and the cloud. So when people talk about the cloud, they're obviously not talking about actual clouds. Your photos aren't floating in the sky somewhere. The cloud is just someone else's computer, specifically massive hard warehouses full of servers called data centers. So, for example, Google has data centers the size of football fields packed with thousands of servers, and these places are pretty wild. They have their own proper plans, massive cooling systems, and insane security. So, your Gmail, your Google hard drives, your Google Photos are all sitting on hard drives in these warehouses. But here's the clever part: companies like Netflix don't just store everything in one place. They use something called the content delivery networks or CDNs. So when you watch a Netflix show, you're not streaming it from a huge server in California. Netflix has copies of all these popular shows stored in data centers all over the world, and you get connected to the one closest to you. So, and this is also getting even more distributed with something called edge computing. Instead of everything happening in massive data centers far away, more processing is happening closer to you in smaller data centers, cell towers, and sometimes even in your router. Um, and now I want to talk more about network security for a minute because this stuff matters. Um, when you see that little log in your browser right next to the website, that means you're using HTTPS instead of the regular HTTP. And the extra S stands for secure. So HTTPS basically it encrypts your data, which basically means scrambling it so that even if someone intercepts it, they can't read it. It's like writing a letter in code that only the recipient can decode. Um, there's also VPNs, which are virtual private networks, which you guys probably know and probably have used before. It essentially just creates an encrypted tunnel for all your internet traffic. And then there's other stuff like two-factor authentication. Um, yeah, so that's like network security. And then yeah, so I ever wonder why your Zoom call is laggy, but your Netflix show works fine, or why your internet is fast at 3 a.m. but slow at 8 p.m. It comes down to two main things, bandwidth and latency. So bandwidth is um like the width of a highway. It's how much data can flow at once. And latency is like the speed limit. It's how long each individual bit takes to get where it's going. So for example, Netflix needs high bandwidth but can handle higher latency. So your video gets downloaded in chunks ahead of time, so a slight delay doesn't matter. But Zoom needs low latency more than high bandwidth. So even though a laggy video call is annoying, a choppy one is completely unusable. And congestion is also something that happens when too many people are trying to use the same routes at the same time. It's like rush hour traffic, but for data. So that's why your internet slows down when everyone in your neighborhood is streaming Netflix at 8 p.m. Let's look at this group of images on the right. This is how deeply like the internet is woven into everything we do on a daily basis, like streaming, smart homes, online classes, video calls, GPS navigation, online shopping, etc. And we use it for almost everything like work, school, healthcare, entertainment, communication. And during the 2020 pandemic with COVID, it literally became a lifeline. People who didn't have good internet access were cut off from jobs, education, etc. And it's not on just on your computer anymore. It's in your pocket, on your wrist, in your car, even your doorbell. So the average home now has over 20 connected devices, which is pretty interesting. Um, but here's the thing: if you look at this map on the bottom right here. As not everyone has equal access to this infrastructure. Internet access in the US now, it looks like a patchwork quilt, and it's not just random. It's because laying these fiber optic cables is very expensive. So running cables to dense urban area where you can serve thousands of customers per mile, that's profitable. But running cables to rural areas where you might serve like 10 customers per mile, that's not often worth it to most companies. So you end up with these things called internet deserts, where people have only one ISP option or slow DSL connections, or they have to rely on expensive satellite internet. And those single option areas are often they often come with higher prices because there's no competition. So this isn't just inconvenient, it's economically devastating. As kids can't do homework, adults can't work from home, small businesses can't compete online, and farmers can't use modern agricultural technology. And I think this really shows this is very made clear in the 2020 pandemic, because suddenly having a good internet wasn't just nice to have, it was essential for survival. So I want to talk about um, now I want to talk about the future of the internet. What are some like few big trends that are shaping where this is all heading? Right now, 5G is rolling out, which uses higher frequency radio waves to send more data, but those frequencies don't travel as far. So 5G needs way more cell towers, which is great for cities, but again, still challenging for rural areas. Satellite internet is also making a comeback with companies like SpaceX's Starlink. So instead of a few big satellites far away, they're launching thousands of small satellites in lower orbit. And this could finally bring decent internet to remote areas, uh, though it's still way more expensive than fiber. Um, and now we're moving away from IPv4 and replacing it with IPv6, which is and we're doing this because IPv4 only has about 4 billion possible addresses, and right now we've got way more than 4 billion connected devices to the internet. So IPv6 can provide enough addresses. In fact, I think it has enough addresses for basically every grain of sand on Earth. So there's like trillions of possible addresses now that are available. And obviously now that AI has become is growing, um, I think AI is trying to optimize internet traffic in real time, so it'll find the fastest routes and predicting congestion before it happens. Lastly, I just want to talk about how understanding this content is it can open up career paths that you might not have considered before, especially if you're working in technology. For example, network engineering, cybersecurity, cloud architecture, DevOps, and site reliability engineering. These are all built on understanding how the internet actually works. So even if you're just a general software engineer or developer, knowing why your API call is slow or why your app works fine in New York but is very slow in Montana, that's the knowledge that makes you better at your job. So next time you send a text, stream a show, or video chat with friends, remember you're not just using some magical wireless technology. You're tapping into this incredible global network of cables, routers, data centers, and protocols that somehow all work together to move your data across the world in milliseconds. Um, and it's honestly pretty amazing that it works as well as it does. So thanks for listening, and feel free to ask any questions on Slack. But yeah, that's my presentation.